All right, let's get into it. We are about to pull back the curtain on something you use every single day, probably without a second thought, your Wi-Fi. Those invisible waves that connect us to, well, everything.
I mean, really stop and think about that for a second. How is it that your favorite show just streams flawlessly to your tablet? How do emails just show up on your phone? It all feels so seamless, almost like it's magic.
But of course, it's not magic at all. What it is a really fascinating story of clever engineering, a bunch of invisible rules, and technology that is constantly evolving. So that's what we're going to do. We're going to pull back that curtain and see how it all really works.
To start, you got to understand the whole point of this technology. At its heart, wireless LANs, or WLANs, are all about solving one huge problem: mobility. It's about the freedom to connect anywhere you want, in your house, at the office, at a coffee shop, without being literally chained to a wall. Now, it's helpful to see where Wi-Fi fits into the grand scheme of things. It's actually just one member of a whole family of wireless tech, and each one is built for a different scale. You've got Bluetooth for a single room, right up to 5G or satellites for global coverage. And Wi-Fi, its sweet spot and our focus today, is right there in the middle, that local area, like your home or office. Okay, so we're untethered, we're free. But now what? The next big hurdle, and it's a huge one, is speed. How do we make it fast enough and reliable enough for streaming movies, for competitive gaming, for everything we want to do online? Well, this has been a constant quest. And you can literally see that journey mapped out in the Wi-Fi standards. The technical name is 802.11, but it's the letters that follow that tell the real story. We started with B and G on that old, crowded 2.4 gigahertz frequency. Then N was a huge leap forward, introducing this game-changing tech called MIMO. AC made things even faster by really focusing on the cleaner 5 gigahertz band. And now, AX, which you probably know as Wi-Fi 6, is all about efficiency, especially when your house is packed with devices. So what is this MIMO thing I just threw out there? It stands for multiple input, multiple output, and it is seriously one of the smartest tricks in modern Wi-Fi. See, instead of just one antenna sending and receiving data, MIMO uses multiple antennas to juggle several streams of data all at once. The analogy here is perfect. It is literally like turning a single-lane country road into a multi-lane superhighway for your data. So with all these devices, your phone, your laptop, your smart TV, all trying to talk at the same time, how do we prevent total chaos? How is it not just a jumbled mess of signals? Well, it turns out there are some key pieces of hardware and a very specific set of rules that keep everything in order. First up, let's meet the players. Inside your phone, you've got the NIC. That's its radio. That radio talks to an access point, or AP, which is the thing creating the actual Wi-Fi signal. Now at home, your router is that all-in-one box that does all of this. But in a big office building, you need a central brain, a WLC, to manage all the different APs and just keep things from falling apart. So how does your phone actually get online? It does this quick, three-step dance every single time. First, it discovers what networks are even out there. Then it authenticates. That's you typing in the password. And once it proves it belongs, it associates to make the final connection. Discover, authenticate, associate. Boom, you're in. Okay, now this part is so important, especially if you've ever had frustratingly slow Wi-Fi. That older 2.4 gigahertz band is like a highway where the lanes all bleed into each other. They massively overlap, so if you're on channel 3 and your neighbor is on channel 4, you're basically yelling over each other. Sticking to channels 1, 6, or 11 is the only way to get a clean signal and avoid a massive traffic jam. And this is why 5 gigahertz is such a game changer. It's like a brand new highway. It offers way more channels, and here's the crucial part. They do not overlap. Every single one is a clean, separate lane. Less interference from your neighbors means a faster, much more stable connection for you. It's as simple as that. Okay, so we've got a fast mobile connection. We're golden, right? Well, not so fast. Because all of our data is literally flying through the air, we've created a whole new problem we have to solve: security. How do we protect our private information from threats we can't even see? And this is a perfect and pretty scary example of why that security is so critical. It's called an evil twin attack, and it's as sneaky as it sounds. A hacker sets up a fake Wi-Fi network that looks exactly like the real one, say at a coffee shop. You connect to it, thinking it's legit, and bam! Everything you do, your passwords, your emails, your banking info, goes straight through the attacker's laptop. So how do we fight back? With encryption. And listen, the most important thing to get from this chart is that not all security is the same. Not even close. Web is completely broken. Just never use it. WPA is outdated. The absolute bare minimum you should be using on your home network today is WPA2. But the real winner, the modern standard you want if your devices support it, is WPA3.
So what's the big deal about WPA3? Well, for starters, it's much better at stopping hackers from just guessing your password over and over. It seriously beefs up the encryption for big corporate networks. And this one is huge. It can automatically encrypt your connection even on open guest networks, like at the airport. That is a massive privacy boost. It even makes setting up smart home gadgets more secure. It really is the new gold standard. So there you have it. From the simple dream of mobility to the complex stance of radio channels and cutting-edge security, that is how your Wi-Fi actually works. But it leaves us with one last thing to think about. As our lives get more and more connected, with smart everything from our watches to our cars, how are we going to have to evolve to keep this invisible, essential world of ours truly secure?